Okay, so I wanted to make a video about phosphate additives. So everybody knows that additives in food are harmful, but a lot of people don't know why. And so when I found out about phosphate additives, actually I found out through um, a legal document, a Morgan& and Morgan legal document, where a bunch of kids that were diagnosed with type 2 diabetes went in there suing these big food corporations for all these additives and all these, terrible things. And so this lawsuit cited a lot of really good research. And so that's where I first found out about these phosphate additives. But I've learned a lot about them since and the bad effects that they can have on your heart. And they're absolutely everywhere. Once my eyes were open to them, like now I seek them out everywhere, and they're so common. So I just wanted to share some of this stuff. Let's see, let me share my screen. Okay, so if we go all the way back to the beginning. So the first thing that we have to understand is that our DNA is absolutely ginormous. Only 2% of it codes for genes. So only 2% of our DNA has the instructions for making different proteins. And I think about those as like machines. They're just pumping out certain proteins, right? The 98% of our DNA is the other 98% is referred to as junk DNA. Come to find out, it's not junk at all. It's actually the part that's responsible for turning those genes on or off. They kind of have the control and they're in charge of the gene regulation, which I would argue is even more important. Um, so, whenever you have these foods that have a lot of phosphate additives in them, um, what it does is it can lead to hormone disruption and it can cause changes in gene expression. So it can cause these certain hormones to go to your heart cells and turn on machines for harmful things like cardiac hypertrophy and fibrosis. So that's obviously not great, but I found it fascinating, so I have to share it. Um, First, I have to understand the difference between organic and inorganic phosphates. The organic ones are the ones in the green box. It doesn't take a chemist to see that they're far bigger and more complex than the inorganic phosphates. What makes them organic is whenever they have a carbon in that structure. And basically, the more complex it is, the more your body has to digest it and take its time to break it down, which your body likes because it likes to be in control. Those inorganic phosphates are such small molecules, they don't need digestion and they just immediately go straight into your bloodstream, and then your body's lost control. It doesn't like that. So, like I said, the inorganic phosphates, 90 to 100% absorption rate. Animal sources of phosphate, organic animal sources, 40 to 60% absorption rate. That's when your body's in control. That's like the best case scenario if you had all of your phosphorus intake from animal sources like meats and dairies and stuff. Then you have plant sources, which is only 10 to 30% absorption, which actually is not really sufficient. That's because most phosphorus is in the form of phytate with plant sources, and we humans, we don't have the enzyme to digest phytate. And plants are really not meant to be eaten by humans at all. They're full of defense chemicals, and like I said, we don't have the enzymes to break a lot of these things down. So in a perfect world, we'd be getting all of our phosphorus from animal sources, and we would be happy. Um, Something I thought when I was looking into this is why isn't faster better? Well, if the phosphate enters your bloodstream too quickly, like I said, your body loses control and it starts to see the phosphate as a threat. So it does everything it can to bring down that level by releasing certain hormones. And the hormones do bring that level down, but that's not the only thing they do. They do other things as well. Um, so, like I said, whenever that phosphate level shoots up because of the inorganic phosphates, you have some things that happen naturally, some passive chemical responses. Like for example, phosphate is negatively charged, so it can, have a natural attractive to a positively charged calcium ion, and that has its own issues. But that's like law of attraction. That's like it just happens naturally. There's certain things that your body deliberately does, certain hormones that it deliberately releases for the purpose of bringing that phosphate level down. So that's an active response. One of those active responses is whenever you have the increased phosphate levels in your blood, your bones are the ones that sense this. And your bones, your osteocytes, they release the FGF23 hormone. And that FGF23 hormone, it usually needs a buddy, Clotho, to be bound to it in order for it to go ahead and affect cells. And I just think of Clotho as kind of like its need for Clotho is almost like an extra level of control that your body has over what the FGF23 hormone does and doesn't do. But there are certain cells in your body that do not need the FGF23 hormone. Um, sorry, there are certain cells in your body that where FGF23 hormone does not need clotho in order for it to bind. So it can act independent of clotho. And that to me is like one less level of regulation that your body has, one less level of control, and one step closer to chaos. So whenever you have increased levels of phosphate, your body goes ahead and releases all this FGF23 hormone. And one of the cells that it does not need clotho to bind to is your heart cells. So it can, without the permission of clotho, it can just independently affect your heart cells. Um, so I think that this image is like really funny. It's this guy with like a train of dominoes. He's going to knock them all down. So this to me is kind of what it's like whenever you have those increased levels of FGF23 hormone. It's like the beginning of the end. It's just the start of this long train that ends in the transcription of genes um, for cardiac hypertrophy and fibrosis in your heart. So for those that don't know, cardiac hypertrophy it's not an increase in the number of heart cells. It's the existing cells, they're just getting bigger. And so your heart muscle gets thicker. And so why is bigger not better with the heart? Because you would think like, oh, it must be a stronger heart. Well, bigger is not better because it actually means that your heart is pumping less blood. It's actually pumping less effectively. If you think of like a balloon that's filled with water, to fill a water balloon, imagine if that balloon, if the rubber was not thin, if it was actually like this thick, then you could fit a lot less water in there. That's kind of like your heart whenever you have this hypertrophy going on. And also in normal cases of hypertrophy, everybody's on the same page. They're like, oh, we need the heart to do more for us. Will you guys get bigger? And they're like, yeah, we're going to do it. And everybody's on the same page and everybody's good. The issue here is that this is happening out of the norm. This increased FGF23 has gotten permission from nobody. Nobody's asked him to do this. He just went ahead and did it. So whenever your heart muscle grows, now your heart needs more oxygen because it's bigger now. But the problem is because nobody's in communication, those capillaries have not increased. So your heart actually doesn't have more oxygen supply, even though it needs more. So then you're at risk of ischemia, which is when you're not getting enough oxygen to your tissues and your cells. And that can cause cell death or it can cause like MIs, heart attacks. And then you have the fibrosis machine also being turned on, which fibrosis is scarring. So then your heart gets all this scar tissue, which actually does two things. It makes it more stiff, and it actually affects the electrical component of your heart because what fibrosis is in between your cells, there's fluid called the extracellular matrix. And fibrosis is whenever there's collagen that's put into that extracellular matrix. And your body does that whenever there's cell death to provide stability. But the issue here is that it also compromises flexibility. So your heart becomes stiffer and that collagen does not conduct energy very well. So it can affect the electrical part of your heart and it can cause arrhythmia. So that's why you have to be careful. But our body really is so brilliant, and you have to think these machines, they're not all bad. There is a purpose for them at the end of the day. This is just these machines being inappropriately turned on. When it is appropriate for them to be turned on is like during puberty when your whole body's growing. Then, you have increased cardiac demand and then your heart does need to grow. That's appropriate. During pregnancy, when you're exercising a lot, you're an athlete, you're asking a lot of your heart. That's totally normal. And then all your body's on the same page and everybody grows together and it's all cool. Same thing with fibrosis. Fibrosis, totally normal. Like if you cut yourself, a scar forms, that's fibrosis. That's totally necessary. With healing, totally necessary and appropriate, but this is just an instance where it's not appropriate. And also all these scary things with the heart. If let's say if my serum phosphate levels increase one time and it's just like really abnormal for me, I don't run around with chronically increased serum phosphate and all this stuff happens to me, it's probably going to be, I'm not going to die from that. The issue here is when you have over and over and over again, if your phosphate levels are always increased and you always have these hormones running around, that's when you actually will develop serious heart disease. So it's the repetition and the continuance and, these little things adding up over time. So this is what the heart cells look like. On the right, you have hypertrophy. So those cells are bigger, you can see, compared to the normal cells on the left. And this is what the fibrosis looks like. You have a normal one all the way on the left, a normal heart. And then you can see that the fibrosis is that increased blue area in the middle image, and on the right, that blue area is that fluid between the red cells, and that's the extracellular matrix where then that increased collagen is going to be added to have that scar tissue. So in this case of the elevated FGF23 hormone, what we're actually looking at is a situation like all the way on the right, that diffuse fibrosis. So it's pretty much everywhere. Again, causing stiffness and potentially arrhythmias. So this is a chart that shows all the different ways that phosphates can be used in foods as additives, which is just honestly, it's so impressive to me. It's like can be used as a flavor enhancer, drying agents, leavening agents, so many different things. It's honestly crazy. And then on the right, it shows how many different phosphates are approved to do that certain job. Um, but most commonly, you'll find phosphates in leavening agents, so a lot of breads and baked goods, and a lot of processed meats, and a lot of processed cheeses, in sodas, and I think also I read TV dinners type of thing, like frozen dinners. So that's where you'll have an extra eye out for those things. So I looked in online at Trader Joe's. Like I have so much fun doing this, looking at the ingredient labels of stuff to see if they have phosphates. And Trader Joe's is unique because it literally, their whole selling point is that they're healthier. I expect the name brand things to have all kinds of additives and stuff, but Trader Joe's literally says like, oh, we make our own version of the name brand thing and it's healthier and there's no artificial preservatives, but there totally is preservatives. I found phosphate in all these things. Their hummus, and there's more. I didn't look at everything. I just looked at stuff that was like interesting to me or stuff that I might guess would have it, and sure enough, it had it. Those pancakes, all these things. Even in a salad kit, you think you're healthy getting a salad. In and out, I looked, it has it in the bun and in the cheese. And then Kraft Singles had it, so that melty type of cheese, those fake type of cheeses, those have it. I looked at Taco Bell Crunchwrap Supreme, had it in the tortilla, had it in the nacho cheese sauce, and in the sour cream. So knowing that, it's probably in every single menu item that they have. Um, and all these oat milks, most oat milks I found had phosphate. I don't think I found one that didn't have one. Not to say there's not. I mean, I wasn't looking so hard to find one that wasn't. All of them just had it. Almond milk, some of them did, some of them didn't. These coffee mate creamers, all of them had it. It was like so crazy. I met a guy who said that one of the biggest changes in his diet is when he got rid of his creamer. He said that he really felt a difference in his body. And I guarantee it's because of the additives. These oat milks, I used to work as a barista and we use these oat milks. I know that many cafes use these same ones. So you can be aware at the grocery store, but anytime you go out and buy something, you're at the whim of whatever that restaurant has decided their ingredients are going to be. Um, and then Coke. Coke has that phosphoric acid, those phosphates in there. So all of these things, anytime that you ingest these, your serum phosphate is going to be elevated immediately, and that's going to trigger hormone responses that are not just going to bring your phosphate down, they're going to do other things like maybe affect your heart. And again, just one soda is not going to kill you, but it's these little things that add up over time. And to me, it's just so devastating when people develop chronic disease and their doctors, they don't have any answers for them as to why. That's absolutely devastating. I mean, like, how could they know at the end of the day? But we really struggle in Western medicine. We're really good at getting rid of the fast killers. Like if you get shot or you have an infection, you know, California is a great place to be. Western medicine's amazing. But as far as chronic disease goes, we really don't take the preventative measures seriously enough. And a lot of that has to do with diet and making good lifestyle and diet choices. Um, so that's why I wanted to make this just to scare people a small amount. Just to scare people a small amount, but mainly to help you guys realize that what you eat matters and you do have power over your health. And you don't want to be stuck in that situation one day where a doctor is giving you devastating news and they have no reason. Oh, your body just randomly decided to do this. Our body is brilliant, is what I've learned, is our body is brilliant. We just have to give it what it needs. We have to understand its language and we have to respect it's intelligent. You just have to kind of be an adult about the things that you eat and not just be like emotionally eating. You have to be consciously eating. And your body will do absolutely amazing things for you. So yeah, there's many more things that happen because of increased serum phosphate levels. But I just have to keep this video controlled because I could go on forever. I just don't want to make you crazy. I can handle the crazy. So there will be more phosphate videos to come. But anyway, that's all I have for now. Thanks.